This video is a test review on factoring polynomials. The first thing you always look for when you're factoring polynomials is, do I have a greatest common factor? On number one right here, I do have a greatest common factor. I have even numbers, so I know 2 will come out. I have ends in both terms, so I know I can pull some ends out. So I'm going to factor this binomial using the greatest common factor. 10 and 14 are even numbers, so I know 2 will factor into both of them. The first term has 3 ends. The second term has 5 ends, so I can take 3 ends out of both terms. So my greatest common factor is 2n cubed. When I factor 2n cubed out of the first term, I am left with 5 because 2n cubed times 5 is 10n cubed. When I factor 2n cubed out of the second term, I am left with 7n squared because 2n cubed times 7n squared is 14n to the fifth. I had 3 n's here, took all of them out, don't have any left. Had 5 n's here, took 3 out, that leaves me with 2 n's. On number 2, I have 4 terms in my polynomial. I first look for a greatest common factor. The fourth term is a constant, doesn't have any variables, so I know I cannot factor an n out. I notice I have 3 even numbers, but this one is not even, so that won't work. 3 will go into 15, but 3 won't go into 10. 5 will go into 10 and 15, but 5 won't go into 12 or 18. There is no greatest common factor on this 4-term polynomial. The first thing you always try is greatest common factor. Didn't work on this one. The second thing I look for is, does it have 4 terms? If it has 4 terms, let's try grouping. Number 2 had 4 terms, so let's go back and try grouping it. When you are grouping a 4-term polynomial, normally you can group the first 2 and the last 2, especially if it's written in standard form like this one is. If this middle sign was positive, I could just go ahead and group. But if I have a negative sign here, I need to go ahead and change subtraction to addition, sign of the next number. Change that subtraction to plus negative so that when you group them, you won't have a negative to distribute, which would mix it up. I have grouped it. Now I'm ready to try to find the greatest common factor on each of these binomials. The greatest common factor on the first binomial is 5n squared. That leaves me with 2n on the first term, and that leaves me with 3 on the second term. I factored 2 of these ends out, left with 1. 5 times 2 is 10. Factored all 2 of those ends out, so no ends are left. 5 times 3 is 15. On the second grouping, I can factor out 6 or negative 6. I know I'm going to need to pull negative 6 out, because if I factor negative 6 out, that's going to leave me with 2n, which will match here. If I had factored positive 6 out, I would have negative 2n, which would not match. And negative 6 times positive 3 equals negative 18. So now I'm ready to write my answer. I accomplished my goal. What's inside parentheses matches. 2n plus 3 matches 2n plus 3. So I'm ready to write my answer. What I factored out, 5n squared minus 6 times what was left in that matches, 2n plus 3. And that is my answer. 5n squared minus 6 times 2n plus 3. Here's number 3. I first look for a greatest common factor. I have a coefficient of 1 on the first, so I can't pull any numbers out. I don't have an n in the third term, so I can't pull any variables out. There is no greatest common factor. If it has 4 terms, I could group. This does not have 4 terms. This has 3 terms. Let's refer back to our note sheet. So no greatest common factor, didn't have 4 terms. I have 3 terms. So I can use the table method if I have a leading coefficient of 1, or swing and divide if I have a leading coefficient other than 1. This one has a leading coefficient of 1, so I use the table method. The table method is right here. Here's an example of that. I want two numbers whose product is this third term constant and whose sum is this second term coefficient. In this example, 1 times 20 is 20. 1 plus 20 is not 9. 2 times 10 is 20. 2 plus 10 is not 9. 4 times 5 is 20. 4 plus 5 is 9. So those are my two numbers, and my answer is x plus 4 times x plus 5. And if I fold that out or distributed the x twice, then distributed the 4 twice, combine like terms in the middle, I would be back to my original question, x squared plus 9x plus 20. So I check my work, it works out. How you know what signs to put here without having to guess and check is right here. This second sign tells you that they're the same. If this is positive, that means both signs will be the same. If they're the same, look at the first sign and it'll tell you what they both are. This says they're the same. This says they're both positive. This says they're the same. This says they're both negative. And if your second term is, or your second sign is negative, then your signs will be different. One of them will be plus, one of them will be minus. So back to our problem, number 3. This tells me my signs are the same. This tells me they're both positive. I have an n square here, so I'm going to go ahead and put n plus times n plus. I'm going to do my table. I could do 1 times 77 is 77, but when I add them together, I get 78, so that doesn't work. 2 won't go in there, 3 won't go in there, 4 won't go in there, 5 won't, 6 won't, 7 will. 7 times 11 is 77. 7 plus 11 is 18. So those are our numbers, 7 and 11, and that is my answer. N plus 7 times n plus 11, or n plus 11 times n plus 7. It doesn't matter what order you multiply. Now I could fold that out and I would get right back to my original question of n squared plus 18n plus 77. Number 4, another trinomial. Let's look at our table here. There is no greatest common factor. There's not 4 terms, but there is 3 terms. The table method won't work. That only works when you have a leading coefficient of 1. So we need to swing and divide. When we have a leading coefficient other than 1, we're going to swing and divide, which means I'm going to take this 6, I'm going to swing it over and multiply it by this 1. That gives me n squared plus 5n plus 6. Now I do use the table method in the midst of this because now I have a leading coefficient of 1. 1 times 6 is 6. 1 plus 6 is 7. 2 times 3 is 6. 2 plus 3 is 5. My numbers are 2 and 3. This tells me my signs are the same. This tells me they're both positive. My numbers are 2 and 3. Now we go back to the swing and divide. I swung a 6, so I need to divide by 6. Simplify these fractions. N plus 1/3. That'll be n plus 1/2. I simplified my fractions, but I still don't have a whole number, so I'm ready to swing back. Swing my 3 back here. That gives me 3n plus 1. Swing my 2 back here. That gives me 2n plus 1. And that is my answer. Swing, factor your trinomial, divide by what you swung, and after you've simplified the fractions, swing back. Now, just for fun, I'm going to FOIL these two binomials and show that we'll get this original question here real quick. 3n times 2n is 6n squared. 3n times 1 is 3n. Now distribute the 1. 1 times 2n is 2n. 1 times 1 is 1. Combine like terms in the middle. I get 6n squared plus 5n plus 1, which is in fact my original question. 6n squared plus 5n plus 1. Number 5 is a binomial. No greatest common factor. It's not 4 terms. It's not 3 terms. So let's check our last thing. If there's 2 terms, you might can do the difference of 2 squares. This is 2 terms. It is the difference. And 4n squared and 81 are all perfect squares. So I can do the difference of 2 squares. The difference of 2 squares, one will be plus and one will be minus. Always, when you do the difference of 2 squares, one will be plus, one will be minus. The square root of 4 is 2. The square root of n squared is n. So the square root of 4n squared is 2n. That goes on the left of both. And the square root of 81 is 9. That goes on the right of both. And that is my answer. I'll FOIL it out just to make sure. 2n times 2n is 4n squared. 2n times negative 9, negative 18n. 9 times 2n is 18n. 9 times negative 9 is negative 81. Combine like terms in the middle. You get 4n squared. Those cancel out. Bring down my minus 81. And I am back to the original question. Difference of 2 squares. Thank you.